Okay, so if we're trying to find how much heat is needed to warm 250 grams of water from 22 degrees Celsius to 98 degrees Celsius, and we know the specific heat of water is 4.18 joules gram per degree Celsius, we're essentially trying to figure out how much heat or how much energy is put into or leaving the system. Now, up to this point, we've only talked about enthalpy change and exchange of heat in theoretical terms. So how do we do it in terms of experimental values? How do we actually go in the lab and figure that out? Well, you need a specific heat. And in particular, we're referring to the amount of energy required to raise the temperature of 1 gram of a substance 1 degree Celsius. We also have something known as the heat capacity, which is raising any substance's temperature 1 degree Celsius, or the molar heat capacity, which is raising 1 mole of a substance 1 degree Celsius. But essentially, they're all saying the same thing, which is that if you know how much of a substance you have, the mass, how many particles essentially, if you know how much energy is required to raise 1 unit of that substance 1 degree Celsius, and you know the change in temperature, you can calculate the exact quantity of heat being released or absorbed. And in this case, we're looking at how much heat is needed to warm 250 grams of water from 22 degrees Celsius to 98 degrees Celsius. Since we know that water is staying in its liquid form at 22 degrees Celsius to 98 degrees Celsius, this equation is actually not super difficult. So, let's watch. First, you have to acknowledge whether or not there's phase change. No phase change in this case. It's staying liquid water to liquid water. So all we need to figure out is how much heat, Q, is needed to warm 250 grams, which is the mass of water, which has a specific heat of 4.18 joules per gram degree Celsius. And that's the specific heat. And then we look for the change in temperature, which is going to be 98 minus 22, or 76 degrees Celsius. And that would be the delta T. So this equation is just a little bit of math, and when I do the calculations, my answer is going to be, when I look at the units, grams cancel out here, degrees Celsius cancel out there, and I'm left with 79,420 joules, or 79.4 kilojoules. And that is your answer.